Good day to all. Here I am going to present our paper titled Nurse-Care Activity Recognition, a GRU-based approach with attention mechanism. In this paper, we propose an approach for recognizing 6 nurse care activities. This problem is initiated by a challenge called the Nurse Care Activity Recognition Challenge. To recognize nurse activities, here we have extracted 4 different sets of features from 2 different sources of sensor data. These 2 different sensor data are from Meditech and motion capture. From Meditech sensor data, we extracted location-based features, and from the motion capture data, we extracted 3 types of features. Out of these 3 types of features, the first one is the geometric features, where we calculate joint-to-joint distance, joint-to-joint orientation, and line-to-line angle. Secondly, we calculate the movement of the right hand or left hand, which called the first level features. Lastly, we extract a second level features where we calculate the relative position of the endpoint of each hand from the shoulder. After extracting this total 4 kinds of features, each of the features set is fit to our proposed model named GRU model with attention as input. Here from each of the 4 models produce a class-wise score vector, and these vectors are finally combined to output the activity class. Now let's discuss the details of the GRU model with attention mechanism. We combine each sample which has 4 sets of features into 30 equal time steps, and which are then fed into the GRU model. One of the good features of GRU is that it captures the long-term dependency and has fewer parameters. Here we add a simplified attention mechanism to the basic GRU units to give more weight to the features which are more relevant. We also use context-dependent attention that exploit the spatial as well as the temporal context of the data. And after that, the 4 attention outputs are concatenated and fed into a fully connected layer. Finally, we use the softmax layer to produce the class-wise score. As 4 different models give 4 different class-wise scores for 6 different activities, we combined each of the model score by adding the class-wise score to take the final decision. Here the class is selected which has a maximum score. Now let's discuss about the experimentation. Here we have experimented our dataset using Haskell's Nurse Care Activity Recognition dataset, which contains 6 activities with 8 subjects. Here we use one subject outcross validation approach to evaluate the performance of our method. We have shown our experimental results for 2 different approaches in table 1. From this table, you can see that the first one is using 1 layer GRU with the attention model, and the second one is using the 2 layer GRU with the attention model. Here we can see that by adding 1 layer, the average accuracy of every model along with combined model increase. Again, we also see that the performance of the combined model is better than that of the individual models. So combining all the models improves the ability to identify complex nurse activities by utilizing all the stated features. The comparison of the average accuracy of 2 different models is also shown in figure 5, which also indicates the superiority of the model with 2 layers than the 1 layer. To measure the performance of our model, we also produce the confusion matrix, which is shown in table 2. Here from table 2, we can see that our model can correctly identify C1, C2, C5 and C6 activities, as these are distinguishable activities. However, for C3, our model confuses with C2 activity, as these two activities have nearly similar movements of hands of the nurse near the patient's hand. After considering all the measurements, so we can say our two layers stacked GRU model with attention performs better than that of one layer GRU model. That's all from this presentation. If you want to know more details about this paper, you can contact one of the authors of this paper. And thank you all.